Okay, let's take a couple minutes talking about the real number system. Numbers actually can be split into two things. They can be real or they can be imaginary. We're not going to worry about imaginary right now. We're going to worry just about real. But reals can actually be defined as all numbers that are on the number line. That's one way to look at the reals. It's all numbers that come in the number line. And there aren't just numbers like 1 and 2 on the number line. There's numbers like pi, which we approximate as 3.14, but pi actually keeps going on without repeating. And so we call it pi because we couldn't actually write out what pi is. So there's all kinds of numbers on the number line. There's, negative fractions. There's going to be, negative decimals. So all numbers that can be represented on the number line are the real numbers. Now within the real numbers, however, we have some categories. So here we have our real numbers. Let's draw you a big circle. These are our reals. Within our reals, we're going to have rationals and irrationals. Okay, rationals are the majority of them. Here are our rational numbers right here. And here are irrational numbers. And let me tell you the difference between those two. Okay, rational numbers can be written as a ratio of a to b. Anything that can be written somehow as a over b as a rational number. Let me give you some examples. 3 is a rational number. It can be written as 3 over 1. Okay. All decimals that terminate or end can be written as a fraction a over b. 0.25 is a decimal that ends. It can be rewritten as 1/4. Okay. All decimals that repeat, such as 0.666666, can also be written as fractions, and so those also are rational numbers. And then, of course, all of your your numbers, your negatives, your fractions, your other decimals, those are all rational numbers. So most of the numbers we deal with are rational. Let me give you an example of what irrational numbers are. Irrational numbers are all your decimals that do not terminate, meaning they keep going on forever, and all decimals that do not repeat. So there's a few examples we pull out when we talk about irrational numbers. Square root of 2 is an irrational number, because let's actually do that on a calculator, and I can show you. If I want to do square root of 2 square root, do you see this number right there? 1.414213564. This is as much as the calculator can give me. This actually keeps going and going. It doesn't ever repeat, and that's what makes it an irrational number. Pi is the same. Pi we often write as 3.14, but actually that isn't an approximation. Okay, pi is not 3.14, it's 3.14, and those numbers keep going on forever and ever and ever and ever and ever. Okay, so decimals that do not terminate or end, or decimals that do not repeat, are irrational numbers. So let's throw some of these in here. Irrational numbers will be numbers like square root of 2, pi, and let's make one up here like 2.4156 ... Let's pretend that goes on forever. Those make them rational. Irrational. Rational numbers, however, a number like 3 halves, like 0.66 that repeats, a decimal that ends, 0.241, and all of these can be negative or positive. Those are all rational numbers. Now within the rational numbers, irrational don't break down anymore, but within the rational numbers, they break down a little bit more. Then we have the integers. And let me tell you about integers. Let me erase and give myself a little bit room here. Integers are easy to get. They are all these numbers. -10, -9, -8, dot, 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 0, 1, 2, 3, dot, 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 keep going direction, keep going that direction. Those are all our integers. There are no fractions that cannot be reduced into whole numbers. Integers, I should say. There are no fractions, there are no decimals. These are all the integers. -10, -9, -50, -102, 1,000,004. Those are all our integers. Within the integers, we also have the whole numbers. And whole numbers are 0 and then all of the positive integers. So 0, 1, 2, 3, 4, dot, 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 dot. So integers have our negatives like -10, -53. Okay. Whole numbers have 0. Then within whole numbers we have one more group that's called the natural numbers. I'm going to put nat for natural numbers. And what you need to know about natural numbers is that there's just one further limitation on them. Give myself a little more room. Natural numbers are just the counting numbers. 1, 2, 3, 4, dot, 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 dot. So we have in here, we have 1, 5, 10, 15. We keep going on. Okay, so natural numbers are 1, 2, 3, 4. Whole numbers are 0, 1, 2, 3, 4, on and on and on. Integers are all the negatives, 0, and positives. Rationals add in the fractions, the decimals that terminate, that means end, the decimals that repeat. Over here are irrationals. Those are numbers that do not repeat or do not terminate, and all of them make up the reals. Now when you're doing this assignment, there are letters that mathematically they assign to these. I don't care if you memorize the letters. They worked well for doing the assignment. The names are what I really want you to know. However, when you're doing the assignment, R represents real numbers, I irrational. Okay, this is where it gets a little weird. Q represents rational. Don't ask me why. Z represents integers. Still don't know why on that one for you either. Whole numbers is W. We're back to the realm of it makes sense now. And naturals are N. And on top of the worksheet, I put those little abbreviations so that you know what they are too.